DeepSeek's newest paper has shown that soon to be released DeepSeek v4 could be the best coding AI model in the world, better than OpenAI and Anthropic, and bring the price of frontier AI coding models 10 times down. Chinese model is already best at this agentic tool use benchmark, and it seems like Chinese models are focusing on everyday use, usefulness, coding, while OpenAI and other companies are more focusing on achieving general intelligence or super intelligence, and that's the difference that's emerging right now. And it seems like Chinese models are gonna be more and more used by everybody in everyday use. A year ago, a single model would dominate every benchmark, but now every benchmark has its own best model, and there is a lot more of a division between different capabilities of models. DeepSeek's CEO, who is also co-author on this paper, is absolutely unwilling to continue massively scaling their compute. They are betting on better algorithms, research, human skill, not just on raw scaling. And it seems like they are starting to win in specific tasks that I predict will be the everyday tasks that we use, while US companies will be focusing more on superintelligence or general intelligence. This paper is basically another invention that shows how to do more with less compute. The idea by DeepSeek here is there is a lot of memory facts that you don't need a lot of compute, so you can just store these memory facts for the LLM somewhere and then it can just retrieve, as opposed to spending compute to think about them. And so it will have more compute for complex logic and thinking, instead of reconstructing these memory facts that are easy to reconstruct by other quick means. If you want to become DeepSeek or OpenAI level researcher yourself, check airesearchmastery.com, link below the video. We have courses and community to mentor and support you in becoming top-tier elite AI researcher. Let's look at this example, it will be easier to understand. Only Alexander the Great could tame the horse Bucephalus. When the LLM sees these words, Alexander the Great, then it needs to think about who this was and the context of this. So then it needs to spend some processing power to figure out it was Macedonian king, student of Aristotle, horse named Bucephalus. It needs to spend computation to add all of this context to its understanding, to the token embeddings. DeepSeek's idea is that we can actually get a bunch of these 3 token or 2 token groups and then just assign all of this context corresponding to these groups and store it somewhere, store it outside of the GPU. And instead of LLM needing to remember and figure out what this is referring to, as soon as it sees these, it can just pull the context, pull information about this in form of vectors, and then just add those vectors, add them to these token embeddings. Let's say the last token it's processing is great. So it sees this, Alexander the Great. Then I'm gonna show you how later, but it's gonna take this to pull vector from the memory that contains all of this information about Alexander the Great. And it's just gonna add that vector, add that information to this last token's hidden state, hidden vector, great. So again, it's just gonna add that information to the last token inside of the layer, because these engrams are only present in some layers in the transformer. And it's gonna add that information, and now there will be more compute for harder reasoning, and it will not have to spend compute on understanding who Alexander the Great was. Don't worry guys, I know it's complex, so I'm gonna go again step by step. First of all, imagine in the memory we have a bunch of these engrams. For example, our 3 grams would be Potter and the. So this is reference from Harry Potter. So the engram would store information that this is about Harry Potter, movies, it could be Philosopher's Stone, it could be other movie endings here, all this information. And that's quickly added to the last word, the, instead of having to process and remember using a large language model, which is a lot more computationally expensive and unnecessary. For example, Princess of Wales, and then vector corresponding to this ID, Princess of Wales, would contain a lot of information about Diana, the Princess of Wales. Since here it's just Princess of Wales, it may also contain information about generally Princess of Wales, not just Diana. But Diana is famous, so there could be a lot of information about Diana as well. This example is shown in the paper. You can dive deeper if you want. If it has piece of cake, that could give a vector that tells it this is just a metaphor, ignore these literal meanings, this means easy. But in the memory, it's just a bunch of vectors. So how do they know that this vector corresponds to Alexander the Great, for example? So they have 3 tokens, in this case, Princess of Wales, for example, and their token IDs, let's say 412 and 95. This is the standard tokenizer in LLMs. And then they have this formula or hashing recipe. So they multiply the first token with some prime number XOR second token prime number XOR third token, and then they get some result. And that's the index of the row that corresponds to Princess of Wales. And then during the training, the model is going to update this row with more and more knowledge as it sees this Princess of Wales and as it learns more about this. Looking at the architecture of this engram, there are 2 main parts. One is retrieving information from memory based on these 2-gram embeddings and 3-gram embeddings. And this hidden input is the second part. This is the actual hidden state within the large language model that's describing the current latest token, the grade, for example. And we will use that to see how relevant this retrieved information is to this hidden state of the LLM. Maybe it's talking about different things, it's not relevant. See here that all of these engrams are concatenated. So let's say you have 8 different heads for these engrams and 8 different heads for these engrams. All of them will be concatenated into a single big vector of all of these 16 pieces of information. And then that vector is processed here through a linear layer to create some kind of key, and here to create some kind of value. So the key will be scale.product multiplied with the hidden input, as I said, the current state in the LLM, to see if both of them are compatible with each other, if both of them are referencing to, let's say, Apple company. Because if this is referencing to Apple fruit and this is referencing to Apple company, then this would be a very low dot product number. So then it wouldn't actually take a lot of information from these engrams, from this memory. And that's how it gets combined and added back into the LLM. And this is done only in certain layers. For example, 2nd layer, 17th layer. And so this way DeepSeek gets improved performance on memory tasks, but even more performance gain on reasoning tasks, because it no longer needs to waste compute on these memory tasks. It has more compute for reasoning. Check airesearchmastery.com, where everything you need to become OpenAI DeepMind level researcher is shown to you step by step. Link below the video, and see you in the next video.